Assalamu alaikum, grade 9. So we're going to be jumping back to chapter 10, which is our last chapter in unit 3, shapes in space, and it's also our last chapter in math 9. But before we get into 10.1, I'm going to just do a little bit of an introduction, talking about different vocabulary, terminology, rules that we need to know to get through chapter 10. Chapter 10 is called Circle Geometry, and it's all about angles and chords and measurements. So you're going to get your 10.1 notes later on, but for now we are just going to be doing some introduction, some terminology, and some definitions. Okay, so the first definition that we need to know is a chord. And a chord is basically a line segment that connects 2 points on the circumference of the circle. Okay, so for example, if you have a point here and a point here, the chord would be the line that connects them together. A chord can be anywhere on the across the circle. Okay, so and it can be as big or as small as you want. So this would be a chord. If you just have from here to here a line that connects them, that would also be a chord. Okay, so a chord is any line that connects 2 points on the circumference of a circle. There's one type of chord that you guys have dealt with before, which cuts a circle directly in half. And that type of chord, whether it's vertical or horizontal, is called a diameter. Okay, so I'm going to write that down, that my pens are not cooperating with me today. When the chord passes through the center of a circle, it's called a diameter. Okay, so a chord is any line segment that connects 2 points on the circumference of a circle. The next definition is a central angle. And a central angle is the angle that forms when two radii, or two radiuses, radii is the plural of radius, meet at the center of the circle. Okay, so basically with a central angle, all angles, guys, are made up of 3 points. Okay, so you know how a chord was made up of 2 points? Any 2 points. An angle is made up of 3 points. And with a central angle, the 3 points, you have 2 on the circumference and 1 in the center of the circle. Okay, so let's say we have this circle right here. If you have a point in the center and you have 2 points anywhere on the circumference, the angle that forms between them, we call this angle right here, we call a central angle. Okay, the central angle can be really big or really small. So for example, if I have an angle like this connecting these 3 points, this angle is also a central angle. Okay, so any angle that connects 3 points, 1 in the center of the circle and 2 in the circumference, is called a central angle. And an angle is formed by two lines that come together. Okay, So you have a line here and a line here, it forms an angle here. Or you have a line here and a line here, it forms an angle here. Or you have a line here and a line here, it also forms a big angle here. If you have a line here and a line here, it would also form an angle. So an angle is always formed in between two lines, okay? Like the letter A. Okay. Our third definition, or our next type, is an inscribed angle. And an inscribed, the word inscribed means written on, okay? So an inscribed angle is technically connecting two chords, okay? Because chords have 2 points on the circumference of a circle. So an inscribed angle is an angle formed by two chords. And we already learned what a chord was. And they have to have a common endpoint. So that have a common endpoint. And then that endpoint has to be on the circumference of the circle. Okay, what do I mean by this? Okay, so let's say you have a chord. These are 2 points on the circumference of a circle. You have a line connecting them, you have a chord, okay? And then let's say you have another chord with this point and a point over here, and then you connect them. So these two chords have a common endpoint right here. It makes this A shape or this V shape, whatever you want to think about it. So we know that an angle is going to form here. What type of angle is it? Well, it's an inscribed angle because it's two chords meeting on the circumference of the circle. That is the key. Okay? The angle that forms from two chords on the circumference of a circle is called an inscribed angle. So this angle right here, and by the way, I'm using the Greek letter theta, which means angle. Okay? So this angle right here is an inscribed angle. Let's say we have another chord here. This a line connects 2 points on the circumference. And then we have another one, this point and this point. And they're connected. This is still an inscribed angle because they have a common endpoint, and their endpoint or their meeting point is on the circumference of the circle. So a chord and a chord meeting together on the circumference forms an inscribed angle. The reason, guys, that you have to know these is because there's going to be some rules that you have to learn between the relationships between inscribed angles and central angles and chords. And so you have to know what these things mean. Okay? So an inscribed angle is when two chords connect, they form an angle. A central angle is when two radiuses connect, they form an angle. And don't forget that a radius is anything from the center to the edge of a circle. Okay, our last definition is an arc. And an arc is basically just a portion or a section of the circumference. Okay, so it's a curved part. It's not a straight line. So let's say you have point A and point B. Okay, the arc would be this curved line between A and B. If there's a chord here between A and B, that is not an arc. Okay, the arc is only the portion of the circumference. So it's this curved part right here. Okay, so you have to know that an arc is just a portion of the circumference, so it's just a curved section. Okay, so these are really, really important definitions. Now we're going to get into some rules. It's just an introduction because you're going to get into them more in 10.1. But these are some things that you have to remember that maybe you may have forgotten. Okay, so we're going to go through them together. So the first fact that you need to know in this unit that you may have forgotten is that all interior angles of any triangle add up to 180 degrees, okay? So if I give you, let's say I give you this angle is 70, this angle is 10, and I ask you what this angle is, you would know that it's 180 minus 70 minus 10, which is 100 degrees, okay? So you need to know that all the interior angles of any triangle add up to 180 degrees. This is an important rule, and you're going to be using it very often. The second fact that you may have forgotten is that what is an isosceles triangle? Well, an isosceles triangle basically has two sides that are the same, and then they also have two equal angles. We're going to be using this a lot. So two equal sides, two equal angles. Okay? So if I cut this, for example, in half, it would make two isosceles triangles. Okay? So let's say this angle is 40 degrees. This angle would be 40 degrees. This angle is 90 degrees. This angle is also 90 degrees. Okay? So it would be two equal sides, two equal angles. Right triangles, we already did this in a couple of our units already, but we know that right triangles can be solved with Pythagorean's formula, which we're going to be using a lot in section 10.2. Okay, so Pythag is coming back, and you guys need to know it for section 10.2. A squared plus b squared equals c squared, and c is always the hypotenuse across from the 90-degree angle. The next fact is that the radius is half the diameter, which you guys all know. The next one is that perpendicular bisectors of two different chords intersect at the center of a circle. Okay, so what that means is that perpendicular means when you cut a line like this. So if you have a line like this, the perpendicular line would be like this. It would create a 90-degree angle. So a bisector means that it cuts the line exactly in half. Bi means two. Okay, so cut in half is what bisector means. So basically it's saying that if you cut a line in half at a perpendicular angle at 90 degrees of two different chords in a circle, they're going to intersect at the center. So for example, if I have a chord here, let me get my line drawn, and I have another chord here. Oops. I guess I'm redrawing my point. Okay, so we have two chords, one here and one here. What this rule is saying is that if you take each line and you cut it exactly in half at a 90-degree angle, okay, and you extend the line, so let's say I take this, I cut it exactly in half. I'm not being 100% accurate right now, but if I cut it in half at a 90-degree angle, and I do the same thing to my other chord, I cut it in half at a 90-degree angle, it's saying that they should intersect at the center of the circle. Okay, so this is true for any chord in your circle. Okay, let's say I have a tiny chord here and here. If I was drawing this accurately, it would still work. If I cut this chord in half, it would still cut through the center of the circle. Okay, so that's what that rule is saying. So it's saying that a perpendicular bisector of two different chords intersect at the center of the circle. That's also going to be important for 10.2. Okay, and the last point says the shortest path between the center of the circle and a chord is a line that's perpendicular to the chord. So basically what it's saying is that the fastest way to get from the center of a circle right here to a chord, you can go here, you can go here, you can go here, you can go here, and so on. But the shortest pathway is the one that is this one right here. This forms a hypotenuse, which should be the longest line. The shortest line, or the shortest way to get to a chord, is by cutting it in half from the center. Same thing here. You can go all the way here, all the way here, 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 but the shortest line is definitely the one that cuts it in half. Okay? That one we're not going to be using that much, but it's something that you should definitely know, because we are going to be dealing with the bisectors a lot. Okay, so our last thing is that that we're going to talk about is 4 properties of circles and line segments that are important to remember. And some of them we already just talked about. So the first one says that the perpendicular line to a chord from the center bisects the chord. So this is the same thing. This is saying the same thing as this point right here. That when you draw a perpendicular line, okay, from the center of a circle to a chord, it's going to cut the chord directly in half. It's going to bisect the chord. Okay, bisect, I'm going to write the definition here in case you forgot. Bisect means cut in half. Exactly. And then perpendicular means at a 90-degree angle. Okay, so it forms a right angle. Why is this important? Why is it important that it's going to form a 90-degree angle? Because with a 90-degree angle, you can then use Pythagorean theorem. So that's why that rule is important. The second property is that, and these ones are important for 10.1. Sorry, these two are important for 10.1, and the last one's important for 10.3. So this is 10.1, 10.1, okay? And this is a rule that you have to know. It's very, very, very important. Okay? So this rule says that the central angle is equal to twice the inscribed angle covering the same arc. Okay? So the central angle is twice the inscribed angle covering the same arc. What does this mean? So let's draw it up. So if we have a circle and we have our center, roughly, that's a big center, say right there. So we have our center of our circle. If we draw a central angle, which remember angle has to have 3 points, and a central angle is 2 points on the circumference, 1 point in the center, and then they're connected. So this is our central angle right here. Okay, let's label it O. And then let's say we have an inscribed angle. Again, remember the angles have to have 3 points. An inscribed angle has all 3 of its points on the circumference of the circle, okay? And remember that an inscribed angle is basically just 2 chords connecting at a point. Now, let's label this inscribed angle I. So what this rule is saying is that when you have a central angle and an inscribed angle sharing the same arc, the same curved part of the circumference, okay? So the central angle, if you wanted to connect it to make a pizza, it would have this arc. And then the same thing with the inscribed angle. If you connect all 3 lines to make a pizza, it would have the same arc, okay? So let's label our points. Let's label this A, B, and C. So inscribed angle, by the way, this is how we write the shorthand for angle. So I'm going to call it angle BAC. Angle BAC. Now, how do you label an angle? Well, you look at how the direction that you have to go to make the angle. You can start here, go here, and then go here, and that would make this angle. So B to A, then to C. You can also say C to A, then to B. It would still make the same angle. So you can say angle BAC or angle CAB. Okay? So this is the inscribed angle that we have, and then we have our central angle, which we labeled as O, but how do we make the central angle? Well, you can start at B and then go to O. So I'm going to call this point O. So you go from B to O to C. So So the central angle would be angle BOC or angle COB. From C to O to B. That would make the angle right there. Okay, so the rule says that when the inscribed angle and the central angle share the same arc, the way that you can know that they share the same arc is that the first letter and the last letter are the same. Okay, remember it's the bottom part of the pizza. That's the arc. So if they're sharing the same arc, then the central angle is equal to twice the inscribed angle. So if the inscribed angle is equal to 40 degrees, the central angle will be equal to 80 degrees, okay? And vice versa. This is something that you guys have to understand, okay? If the central angle is equal to 100 degrees, the inscribed angle would be 50 degrees, okay? The central angle is always double the inscribed angle if they share the same arc. So that's the first rule that you guys are going to go into depth with in 10.1. Okay, the second rule is that when you have, by the way, so when you have inscribed angles subtended by the same arc, they are congruent. So let's break down the sentence. Inscribed angles, we know what they are now. Subtended means, subtended by the same arc means that they share the same arc, or they are built by the same arc. Or in other words, they share the same pizza crust. That's how you can think about it. Okay, so two inscribed angles that share the same arc, okay, are congruent. The word congruent means exactly the same. Okay, so for example, again, I'm going to draw some angles. So remember, an inscribed angle is 3 points, and all 3 points are on the circumference. It's basically, what is happening? 2 chords connecting together. So that is inscribed angle number 1. Inscribed angle number 2, they have to have the same arc, right? So point 1, point 2, I'm going to put the third point right here. I'm going to connect them. So chord and chord. Now I'm going to label my angles. So I'm going to call this point A. Sorry, I label my points. Point A, point B, point C, and point D. Okay, so here we have 2 inscribed angles. We have angle ADB, which is this one right here. And we have, or you can also call it angle BDA. It doesn't matter what you call it. And then you also have angle ACB right here, or angle BCA. So both of these, if you connect them and you make a pizza out of it, they both have the crust part of the pizza as the arc from A to B. Same thing with this one. If you connect it and you make it a pizza, it's a weird shaped pizza, but it's a pizza, the crust part is still the arc from A to B. Okay? So these are 2 inscribed angles that share the same arc. So that means angle ADB will be equal to angle ACB. Again, you can know that they share the same arc if the first and last letters are the same. That means that they share the same arc. Okay? So that means that if angle ADB right here is 30 degrees, then this angle right here is 30 degrees. Okay? So how are you going to use this or these 2 rules specifically? What we'll do is we'll probably be giving you questions with a bunch of angles missing in a circle, and you have to use the rules that you've learned in order to find all the missing angles. Okay? So these 2 rules are really important for you to know. The last one is also important, but it's going to come back again in section 10.3. Okay, so the last point says that when you have a tangent to a circle, it's perpendicular to the radius at the point of tangency. Again, let's break it down. So a tangent line is a tangent to a circle, sorry. So a tangent line is any line that touches the outside circumference of a circle at one point only. Okay, we're going to cover this more in 10.3. So basically a tangent line is like on the outside of a circle. Sorry, my lines are a little bit off. But basically it's on the outside of a circle, and it only touches the circumference at one point. We call this point the point of tangency. Okay, so the point where the tangent touches the circumference. Okay, so whenever you have a tangent line, you have a point of tangency, which is where it's actually touching the circle. This rule is saying that when you draw a perpendicular line to the tangent line, right here. Oops, let me use a different color. When you draw a perpendicular line to the tangent line, okay, that perpendicular line is basically the radius of the circle. Okay, so anywhere you draw a tangent line, sorry guys, my drawing is really off because my hands are not steady. So anywhere you draw a tangent line, if you draw a perpendicular line to the tangent, it's always going to be a radius, always. Okay, and that's our last point. So don't be overwhelmed with these rules yet, because we're going to go into a lot of depth with them. This is just an introduction to get you guys kind of introduced to the idea of the rules of a circle and geometry and angles and how to label angles and stuff like that. Okay, so in 10.1, you're going to be focusing on central angles and inscribed angles. In 10.2, you're going to focus on perpendicular lines or perpendicular bisectors. And in 10.3, you're going to focus on tangents. Okay, so this was just a brief introduction. It's a lot of new information. The most important thing from this topic that you get, guys, is the vocabulary, and start thinking about these rules, because these rules are going to be really, really important in the coming sections. Thank you guys for listening. That's all I have for you today. There is no homework from this introduction, and I'll see you guys later, inshallah. Assalamu alaikum.